Hello and welcome to this lesson about square roots and cube roots. The learning target of this video is finding the square and cube root of numbers. So first, I want to start off with a major core idea. And so we're going to write this in red. Roots undo exponents. And so that is the big idea that we need to address right now. Square roots and exponents are inverses to each other, or roots and exponents are inverses. And so if we see something like x squared and we take its square root, this is going to equal just x. All right, and so that's what roots are useful for. Roots, square roots or cube roots or any kind of root we use helps us undo an exponent. So now let's talk about square roots. So square roots, first of all, here's the symbol for it. And this symbol we call the radical. And so for those of you when you get to algebra, we'll talk more about this and we'll make things a little more complicated. But that means that we're taking a square root. And what a square root is we are looking for two identical factors. Identical factors. Two identical factors. I cannot stress that enough. And so what that means is this works well on perfect squares. So I want to go back a slide here, and let's take a look at some numbers here. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, and we'll just leave it at that. Now, we're going to take these numbers, and if we square them, we'll get 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 16, 25, 36, 49, 64. And what's going to happen is if we were to go the other way, so like -1, -2, -3, -4, we're going to see a similar pattern arise. 1, 4, 9, 16. These numbers right here are the ones we have to look out for. We need to know these numbers. And you should know the perfect squares up to about 20. And because that's what the square root does, is it undoes them. We're looking for two identical factors. So for example, let's say we're looking at something like, what is the square root of 81? Well, what we're doing is we're taking 81 and we're breaking it down to its factors. 9 times 9. And so we have right here two identical factors. It comes out as just one of the 9, as 1 9. So actually, let me erase that, clean it up a little bit. So that's going to come out of the square root as a single 9. So the two identical factors come out as 1. We take a look at the square root of 25. We break that down. That is 5 times 5. So that will equal just 5. We're looking for two identical factors, and then it gets written as one of them. As one of them. Let's write that part there. Very cool. So that's square rooting. That's all it is. So if you know perfect squares, you just undo them. That's what's going on there. Now, a couple things I have to say, because it's a mistake that many students make all the time, and it's very frustrating. Oh, try erasing that again. There we go. So a couple things that it is not. So square roots are not. First one, dividing by 2. I cannot tell you how many times I see this. Square root of 6 is equal to 3. That is not the case at all. All right? Your thought process isn't, hey, let me see, 48, and take the square root of it. Oh, I'm just going to say it's, 2 times 24, therefore it has to equal 24. You're not dividing by 2. You're looking for two identical factors. The second thing, and this one's a little more well, it's simple to remember, complicated to explain. You cannot take the square root of a negative number. So the square root of negative 4 has no answer yet. We'll talk about that a little bit later. Or you might find out more about this in high school. But when you're taking the square root of a negative number, you don't have an answer. Because for a number to be negative, let's think about how you can get negative 4. You get 2 times 2 will give you the 4 part, but one of these 2's has to be negative. And once you do that, you no longer have 2 identical factors. They're not the same. And that's just how you get a negative number. You have to have a positive and a negative, and that gives you the negative 4. But in order to have a square root, you need to have 2 identical factors. And so it's so close. It's so tempting, but it's just not possible. So you've got to keep that in mind with square roots. Now, let's talk about cube roots. So cube roots, the notation you use in the radical, but notice that there's a 3 up there. So this lets us know that we're taking a cube root. And for square roots, we're looking for 2 identical factors. For these, so for cube roots, we're looking for 3 identical factors. And so for this, it helps to know our perfect cubes. So let's go back to our list right here, and let's kick it up a notch. So we've done the perfect squares. Now let's do cubes. So what's 1 times 1 times 1 times 1? 1. 2 times 2 times 2? 8. 3 times 3 times 3 is going to be 27. Here we get 64. 125. Oops, 125. 216. 343. 512. And these are just things you have to commit to memory. All right. Now, the catch is that if we do this with negatives, we'll get the same number, the same digits, but with a negative sign. So negative 1 times negative 1 is positive 1. Times it by negative 1 again is negative 1. Same thing. You take negative 2 times negative 2, positive 4. Times it by negative 2, negative 8. Negative 27, negative 64. And that has some ramifications a little bit later. But when it comes to taking cube roots, you have to know these, and then you just undo it. It goes back to that core idea. Roots undo exponents. So back up here, the cube root of x cubed is equal to x, whatever that number is. And so, oops, that's square roots. Let's talk about some cube roots. So we're looking for 3 identical factors. So if we have the cube root of 125, that equals 5. Cube root of 8 is equal to 2. Cube root of negative 1 is negative 1. So watch out for those negative signs. Those negative signs will matter. We can have a negative cube root. That does work, okay? And so, yes, let's do another one. Let's say actually, let's do 2 more. So cube root of negative 64 versus the cube root of positive 64. So 64 is a perfect cube, and it is 4 cubed, so it just becomes 4. Or this one's negative 4 because it's negative 64, whereas the positive 64 one is positive 4. So that's what it boils down to, is knowing your cube roots, or your perfect cubes, so you can undo that. Last thing I want to talk about is just sort of a loose end here with square roots. So let's jot that down here. Okay. Principal square root versus x squared. So if I say, what is the answer to, whoops, not that. What's the square root of 64? That equals 8. However, if I'm like x squared equals 64, what I would do is take the square root of both sides. And here I'm going to get x could equal negative 8, or x could equal positive 8. Because if you were to go negative 8 times negative 8, you'll still get positive 64, just as if you were to do 8 times 8. So the point I want to highlight here the principal square root has to be positive. So think principal positive. And then x squared equals something is going to give you 2 answers. It's just one of these technicality things. So technically the principal square root is just the positive natural number. But when you put it into an equation and you go to solve, you could actually get 2 answers. It's possible for that to happen. So that's how we find square roots and cube roots. Again, this ideas I want to stress is that it's all about finding identical factors. So for a cube root, you're looking for 3 identical factors. So how 125 is 5 times 5 times 5. For square roots, I've erased it, but we're looking for 2 identical factors. You know those things, you're set up for success. So good luck with your homework or practice, and let me know if you have any questions.